Okay, so the next focus question is talking about solubility and using table F as far as whether or not different compounds are soluble in aqueous solutions, which means with water. We already used this table earlier on. We did a lab with it. I think it was even a day that I was getting observed when we went over the questions. So this is kind of a review of that and revisiting it now in the solubility chapter. So if you remember from this table, these are all of the ions that are soluble with the exceptions. So if we look at group 1 ions, everything in column 1, those are all soluble. All ammonium compounds are soluble. Anything with nitrate, acetate, hydrogen carbonate, and chlorate, with no exceptions. So all of these are always going to be soluble in water. Okay. Then, down to chlorate too. Then halides, so chlorine, bromine, and iodine, the halogens, are always going to be soluble except if they're with silver, lead, or mercury. So if I had silver chloride or silver iodide, that would be insoluble. And then all sulfates are going to be soluble except if they're with the same above, silver and lead, but then calcium, strontium, or barium. So if I have barium sulfate, it'll be insoluble. But if I have lithium sulfate or sodium sulfate, those will be soluble. So I usually focus mostly on this side with what's soluble with exceptions, unless I don't see something come up here, and then I'll go over here. So these are the ones that are insoluble with their exceptions. So all carbonates are insoluble except if they're with group 1, because we already know all of the group 1 are soluble, or ammonium, because we already know all the ammonium are soluble. Same thing with chromate, they're all insoluble except if it's with group 1, except if it's ammonium or calcium or magnesium. All phosphates are insoluble unless they're with group 1 or ammonium. Sulfides are all insoluble unless group 1 or ammonium, and hydroxides. Okay, so what we're going to do now is look at these. So when silver nitrate and sodium chromate are mixed, will an insoluble product form? So we have silver nitrate. So first I'm going to write silver nitrate. So silver is Ag with a +1. So it'll kind of give you a good review of stuff we've done. Nitrate is NO3 with a -1. So that gives us AgNO3 for silver nitrate. It's combining. Sodium is Na with a +1. Chromate is CrO4 with a -2. So if we crisscross, that's going to be Na2CrO4. So those are two compounds. So that's going to be a double replacement. So this is our one where the metals are going to swap places with each other. So now the sodium is going to be with the nitrate. Sodium's +1, nitrate's -1, so NaNO3. And now the silver is going to be with the chromate. Silver's +1, chromate's -2, so Ag2CrO4. So those are going to be our products. So NaNO3 and AgCrO4. If they needed us to balance that equation, if this was a multi-part question, then we have 2 silver here. We would need 2 silver here. And we have 2 Na here and only the 1 here, so we would need a 2 there. Sorry. I kind of continued up to here. Sorry. Okay. All right, so these are our 2 products, sodium nitrate and silver chromate. So we want to see whether or not they are soluble or insoluble. So silver nitrate, if I come up here, I see that all nitrates are soluble. So this is going to be soluble. So if I had to write its state, it'd be aqueous. It'd be dissolved in water. Then silver chromate. So if I look up here, all chromates are insoluble except if they're with group 1. So if I look, silver is not in group 1. It's not in the first column. If it's with calcium, magnesium, or ammonium. So this one will be my insoluble product. So this one would be as a solid. Okay. All right, next one. Barium nitrate and sodium sulfate are mixed together and then poured through a filter. Will a solid remain on the filter? So if they're mixed together, we have barium, which is +2, nitrate, which is -1. So we have barium nitrate. Sodium sulfate, sodium is +1, sulfate is SO4 -2. So Na2SO4. We have two compounds. This is going to be a double replacement. So Na is going to be with the NO3 and Ba is going to be with the SO4. Barium is +2, sulfate's -2, so BaSO4. So those are our products. If we had to balance it, we have two NAs here. We need two NAs there. All right, so now these are our products: sodium nitrate, barium sulfate. So nitrates, we know, are all soluble with no exceptions. So this one is soluble. So AQ. Barium sulfate. So what do we got? Oh, here, sulfates are all soluble except if they are with barium. So this one is going to be insoluble. So that means then if I poured them through a filter, will a solid remain on the filter? Yes. Barium sulfate will stay on the filter. All right, and then the last one, a 1 gram sample of a compound is added to 100 grams of water and stirred. Some of the compound was then separated by a filter. Based on table F, this compound could be. So in other words, which one was solid so that way it separated and stayed on the filter. So now we just have to see which one of these is listed as insoluble up here. Okay, so we've got silver chloride, calcium chloride, sodium chloride, nickel chloride. So they all have chloride. So if I come up here, I see here's the halides. So chloride. They're all soluble, except if they're with silver, lead, and mercury. So now if I come down here, all the chlorides are soluble, except if they're with silver, lead, or mercury.